Okay, hello everyone. In a new video. In this one we are going to introduce a method which directly allows us to locate the image of the object. So we all know in optics, whenever a luminous object AB placed in front of a lens, we can determine or trace the image A prime B prime of the object AB given by the lens L by considering two incident rays issued from B, in which we know how to complete their path. So if we consider the first one parallel to the optical axis, this ray will emerge passing through the image focus. And if you consider another one issued from B passing through the optical center, it will emerge without deviation. And we know that the point of intersection of the emergent rays is the image of the object B, and A prime, the image of A, will be the foot perpendicular of B prime on the optical axis. So this is the tracing of the image A prime, B prime. However, in most of the cases, the tracing of the image using this method is not accurate, and this depends on several parameters. For example, the graph paper that we are using, the ruler, and the pencil as well. So now in this video, we are going to introduce a new method which allows us to directly to locate the image B prime of the object B without tracing any rays. Then let's start by explaining this method. So this is the axis x prime x, so this is the positive direction and this is the negative direction. We will also consider the y-axis to be the axis perpendicular to the optical axis at the optical center O. So this is the positive y-axis, so this is y prime. So this y prime, this is the positive direction and this is the negative direction. Now, in order to locate the point B prime of the object B, first we need to identify the coordinates of the point F prime and the point B. So the point F prime is given by x F prime and y F prime, and the point B is given by xB and yB. So recall in math that we call that the first one corresponds to the x and the second one corresponds to the y. So we call the x to be the abscissa and we call the y to be the ordinate. So the point B is given by the coordinates xb, yb. xb is said to be the abscissa and yb is said to be the ordinate. So now let's identify the coordinates of each point. Let's start with the point B. So the point B has an abscissa 1, 2, 3, minus 3, and has an ordinate plus 1, whereas the point F prime has an abscissa 1, 2, whereas the coordinate of the point F prime is 0 because it's located on the x-axis. So now after we have located or identified the coordinates of the point B and F prime, now we can calculate the coordinates of the point B prime, which is the image of the point B. So now the abscissa x of the point B prime is given by xb multiplied by xf prime divided by xb plus xf prime. So now the value of xb is given by minus 3 multiplied by xf prime, which is 2, divided by, now the value of xb is minus 3 and the value of xf prime is plus 2. So this will give us minus 6 divided by minus 1, which is equal to plus 6. So the value of x is equal to plus 6. And now let's calculate the value of y. So y is given by yb divided by xb multiplied by x. So here x is the value that we have just already calculated, which is plus 6. So now the value of yb is given by 1 divided by xb, which is minus 3, multiplied by 6. So this will give us 6 divided by minus 3, which give us minus 2. So y is equal to minus 2. So recall that what does x and y represent in this case? They represent the coordinates of the point image B prime. So b prime in this case is given by 6 and minus 2. So now we can directly locate the image b prime of the point object b. So the abscissa is given by 6. So now let's count 1, 2, 3, 4, 5, 6. And minus 2. So minus 2 means that we need to count 2 divisions downward. So 1, 2. So this point will be b prime. But notice that this method is not part of the answer. Okay, so after we have now located the point b prime, we must erase this, because this is not considered as part of the answer. Okay, now after we have located the point image b prime of the object b, now we can trace rays of light issued from b. So this is the first one parallel to the optical axis. So now after we have located the point b prime, we know that this ray will emerge going to b prime like this. And now another one issued from b passing through the optical center will go to b prime. So using this method now, before drawing the ray of lights, we have directly located the image b prime of the point b. Then after we locate the image b prime of the point b, we can trace the ray of lights. And we already know that they will pass, the emergent ray will pass through the point b prime. And in this case, we will guarantee that the tracing of the image will be correct. Okay, so let's consider another example. Just a side remark, this method works for any case, and not only for a converging lens but also for a diverging lens, as we shall see. Now for example, in this case we need to trace the image a prime b prime of the object AB. So before we do the tracing, let's locate the image b prime of the point object B. So this is the positive direction of the x-axis, this is the negative direction, this is the positive direction of the y-axis, this is the negative direction. So the first thing that we will do is locate the coordinates of the point B and the image focus f prime. Here the image focus is not given, but we know that it is the symmetric of f with respect to O, so this is f prime. So now the point B has the coordinates of 1 division in the negative direction and 1 division for the ordinate in the positive direction. So B is given by minus 1, 1. And the point f prime is 2 divisions on the x-axis, so it's given by 2, 0. So the value of the ordinate 0 because it's located on the x-axis. Now let's calculate the value of x. So x is given by xb multiplied by xf prime divided by xb plus xf prime. So the value of xb is given by minus 1 multiplied by xf prime, which is 2, dividing by xb, which is minus 1 plus 2. This will give us minus 2 divided by plus 1, which is minus 2. So the value of x in this case, minus 2. And now let's calculate the ordinate y. Y is given by yb divided by xb multiplied by x. So the value of yb in this case is 1 divided by xb, which is minus 1, multiplying by x. We have already calculated the value of x and is given by minus 2. Okay, this is multiply. So this is given by minus 2 divided by minus 1. This will give us plus 2. So the value of y is plus 2. Therefore, in this case, the coordinates of the point B prime is given by minus 2 plus 2. So now let's locate the point B prime in the orthonormal system or on the graph. So xb is equal to minus 2, so we count 2 divisions in the negative direction, so 1, 2. And the plus 2 means that we count 2 divisions upward, so 1, 2. This will be the point B prime of B. And I repeat, this we do it on the scratch. It's not part of the answer. Okay, so here we are We are just locating the point B prime before we do the tracing. So now let's erase everything. So we know that B prime will be here. Then if you consider incident ray issued from B parallel to the optical axis, this is F prime. We know that this ray will emerge passing through the image focus. And if you consider another one passing through the optical center, it will emerge without deviation like this. So the two emergent rays, they don't intersect in front of the lens, therefore behind the lens, therefore we need to prolongate them backward. So we know that the prolongation will pass through the image B prime as well as for the prolongation of this ray. Okay. And for sure A prime will be the foot perpendicular of B prime on the optical axis like this. Let's also consider another example. So in this case, we need to locate the image of the point B. So first, as we usually do, let's locate the coordinates of the point B and the point F prime. So the point B is located 1, 2, 3, 4, 5 divisions behind in front of the lens. So in the negative direction, this is the negative direction, this is the positive direction, this is the positive direction of the y-axis, this is the negative direction of the y-axis. So B is given by -5 and 1 division upward, and the point F prime is given by 3 divisions on the x-axis and 0 divisions on the y-axis. So X is given by XB multiplied by XF prime divided by XB plus XF prime. So the value of XB is given by -5 multiplied by XF prime, which is a 3, divided by -5 plus a 3. This will give us -15 divided by -2, so this is 7.5. And now the value of y is given by YB divided by XB multiplied by X. So the value of X here we have already calculated, which is given by 7.5. The value of YB is given by 1. And the value of XB is given by -5 multiplied by 7.5. So this will give us 7.5 divided by -5. So if we plug this on the calculator, it will give us -1.5 divisions. So the coordinates of the point B prime is given by 7.5 and -1.5. So now let's locate the point B prime, the image of B. So if we count 1, 2, 3, 4, 5, 6, 7, 7.5, and we count 1.5 divisions but downward because we have a minus sign here. So this will be the point B prime of the object B. So now let's erase everything. And now let's trace incident rays from B and check whether they pass through the image B prime. So the first one is parallel to the optical axis. We know that it will emerge passing through the image focus like this. And another one passing through the optical center, it will emerge without deviation. And by this, our drawing will be completely correct. And for sure the point A prime will be the foot perpendicular of B prime on the optical axis. Okay. So let's consider also another example. We need to trace the image A prime B prime of the object AB. So first let's identify the coordinates of the point F prime and the point B. So this is the positive direction of the x-axis, this is the negative direction, this is the negative direction, this is the positive direction of the y-axis. The point F prime has the coordinates, let's start with the point B. The point B has the coordinates of 1, 2, so -2, and an ordinate of +1. And now the point F prime is located 1, 2, 3 divisions on the optical axis, so it's given by 3, 0, or on the x-axis. Now we can calculate x and y, the coordinates of the point B prime. So x is given by xb multiplied by xf prime divided by xb plus xf prime. So this is equal to, the value of xp is given by -2 multiplied by xf prime, which is a 3, divided by -2 plus 3. This will give us -6 divided by 1, which is equal to -6. Now the value of y is given by yb divided by xb multiplied by x, and this is equal to, the value of yb is given by 1, the value of xb is given by -2, multiplied by the value of x, which you have already calculated, which is -6. So this will give us -6 divided by -2, which is equal to 3. So the value of y is equal to 3, and the value of x is equal to -6. So the coordinates of the point B prime is given by -6 and 3. Okay, so now let's locate the point B prime before tracing the image. So -6 means that we need to count 6 divisions backwards, so 1, 2, 3, 4, 5, 6. And 3 means that we need to count 3 divisions upwards, so 1, 2, 3. So this is the position of the point B prime. Now let's erase everything, because I repeat that this must not be a part of the answer, so either we erase it or we do it on the scratch. And now let's trace the image using incident rays. So this is the first one parallel to the optical axis. We know that it will emerge passing through the image focus, another one passing through the optical center, and by this the emergent rays don't intersect behind the lens, therefore we need to prolongate them backward. This is the prolongation of the first emergent ray, prolongation of the second emergent ray, and as we can see, they intersect at the point B prime, and A prime will be the foot perpendicular of B prime on the optical axis like this. Now let's also consider this example. Let me see. Okay, so yeah, let's look at, so this is the positive direction, negative direction, positive direction of the y-axis, negative direction of the y-axis. So the point B has the coordinates of 1, 2, 3, 4 divisions backward, so -4, and 1 division upward, and the point F prime is given by 1, 2, 3 divisions, and 0 because it's on the optical axis. So now x is equal to xp multiplied by xf prime divided by xb plus xf prime, which is equal to, so the value of xb is given by -4, and the value of xf prime is given by 3. So -4 plus 3, this will give us -12 divided by -1, so x is equal to +12. And the value of y is given by yb divided by xp multiplied by x. So the value of xp is given by -4, sorry, +1. And the value of xb is given by -4 multiplied by the value of x which we have already calculated, which is +12. So this will give us 12 divided by -4, which will give us -3. So the value of y is equal to -3, and the value of x is equal to +12. So we know that the coordinates of the point B prime is given by 12 and -3. So now 12 means that we need to count 12 divisions in the positive direction, which means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and which confirms that the image will be on the screen. So this is here. And -3 means that we need to count 3 divisions downward. So 1, 2, 3. So this is the position of the image B prime. Now let's erase everything. Then now let's trace the image, knowing that it's located here. So the first one parallel to the optical axis will emerge passing through the image focus like this. The second one passing through the optical center will emerge without deviation. And for sure the point A prime will be the foot perpendicular of B prime on the optical axis. So this is the image. Let's consider another example. So here first let's locate the point f prime. So f prime is the symmetric of f with respect to O. So this is the positive direction, negative direction, positive direction and the negative direction. So the point B has the coordinates 1, 2, 3, 4, 5, 6, minus 6, and 1 division upward. The point F prime 2 by 0. Okay. So now the value of x is given by xb multiplied by xf prime divided by xb plus xf prime. So the value of xb is given by minus 6. The value of x prime is 2. So minus 6 plus 2, this will give us minus 12 divided by minus 4. So x is equal to 3. Now the value of y is given by yb divided by xb multiplied by x. So the value of yb is 1 and the value of xb is minus 6 multiplied by the value of x, which we have already calculated, which is 3. This will give us 3 divided by minus 6, which is equal to minus 0.5. Then the value of y is equal to minus 0.5. So the point B prime has the coordinates 3 and minus 0.5. So now let's locate the point B prime. 3 divisions in the positive direction, 1, 2, 3, and minus 0.5 divisions downward because of the minus sign. So the point B prime will be here. Now let's erase everything. So an incident ray issued from B parallel to the optical axis will emerge passing through the image focus like this, and another one passing through the optical center will emerge without deviation. So this is the tracing. So all of the previous examples were the cases of a converging lens. Now let's check that also this method works for a diverging lens. As usual, let's locate the coordinates of the point B and the point F prime. So the point B in this case, 1, 2, 3, 4, so minus 4 divisions and 2 divisions upward. And the point F prime 1, 2, 3, 4, minus 4, and because it's located on the x-axis, the ordinate will be 0. So now the value of x is given by xb multiplied by xf prime divided by xb plus xf prime, which is equal to, so the value of xb is minus 4, the value of xf prime is also minus 4, divided by minus 4 and minus 4, so this will give us plus 16 divided by minus 8, so x is equal to minus 2, the value of x is equal to minus 2. Now the value of y, which is given by yb divided by xb multiplied by x, so the value of yb in this case is 2, and the value of xb is minus 4, multiplied by x, which we have already calculated, which is minus 2. So 2 multiplied by minus 2 will give us minus 4 divided by minus 4, this will give us plus 1, so y is equal to plus 1. So the coordinates of the point B prime is given by minus 2 and 1. Now let's locate the point B prime. So minus 2, we count 2 divisions in the negative direction. This is the positive direction. This is the negative direction of the x-axis. This is the positive direction of the y-axis. This is the negative direction of the y-axis. So minus 2, 1. Okay, 2 divisions backward and 1 division upward. This is the point B prime. Now let's erase everything. So if you consider an incident ray issued from B parallel to the optical axis, because it's the case of a diverging lens, this ray will emerge as if coming from the image focus F prime, like this. And if you consider another one passing through the optical center, will emerge without deviation. Now notice that the emergent rays, they don't intersect behind the lens, therefore we need to prolongate them backward. So we have already traced the prolongation of this emergent ray. Now the prolongation of this emergent ray is given like this. So the prolongations intersect at the point B prime, which is the image of B, and for sure A prime will be the foot perpendicular of B prime on the optical axis. Okay, so let's also consider this example. This example is the case of a converging lens. Let's locate the coordinates of the point B and the point F prime. So the point B is given by 1, 2, 3. So this is the positive direction, this is the negative direction, this is the positive direction, and this is the negative direction. So the coordinates of the point B are given by 1, 2, 3, so minus 3. And because the point B is located in the negative y direction, so it's given by minus 2. Now the point F prime is located in the positive direction, 2 divisions, so it's 2. And it is on the x-axis, so it's 0. So now x is equal to xb multiplied by xf prime divided by xb plus xf prime. So minus 3 multiplied by 2 divided by minus 3 plus 2, this will give us minus 6 divided by minus 1, so the value of x is given by 6. Now let's calculate the value of y, which is given by yb divided by xb multiplied by x. yb is equal to minus 3, xb is equal to minus 2, the value of x we have already calculated, which is 6. This will give us minus 18 divided by minus 2, so the value of y, sorry, here I have done a mistake. The value of yb is minus 2, the value of xb is minus 3, and multiplying by x, which is 6. So minus 12 divided by minus 3, this will give us plus 4. So the value of y is plus 4. Now the coordinates of the point B prime is given by 6, 4. So 6 divisions in the positive x-axis, 1, 2, 3, 4, 5, 6. And 4 divisions upward. So this is the point B prime. Now let's erase everything. So this is incident ray parallel to the optical axis. It will emerge passing through the image focus like this. And if you consider another one passing through the optical center, it will emerge passing without deviation. And in this case, A prime will be the foot perpendicular of B prime on the optical axis. This is the hat which is pointing away from the optical axis. Okay, so this is the tracing. Okay, the last example for this video. Now, here the positive direction for the x-axis is on the left. And on the right will be the negative direction, because the direction of propagation of light is from right to left, and the positive direction of the x-axis will be to the left. So this is also plus, and this is also negative. So the direction or the orientation of the y-axis will not change. Now let's locate the coordinates of the point F prime and the point B. So the point B is located 1, 2, 3, 4 divisions in the negative direction, and 1 division upward, whereas the point F prime is located 2 divisions in the positive direction, and the value of the ordinate is 0 because it's located on the y-axis. So now the value of x is given by xb multiplied by xf prime divided by xp plus xf prime. So this is equal to the value of xb is minus 4, the value of xf prime is 2, divided by minus 4 plus 2. This will give us minus 8 divided by minus 2, which is equal to plus 4. So the value of x is equal to 4, and the value of y is yb divided by xb multiplied by x, which is equal to the value of yb is minus 1 divided by minus 4 multiplied by 4, the value of x that we have already calculated. This will give us 4 divided by minus 4, which is equal to minus 1. So y is equal to minus 1. So now we know that the point B prime will be 4 and minus 1. So 4 divisions in the positive direction, this is the positive direction, 1, 2, 3, 4, and minus 1 division downward, so this is the point B prime. And now let's check by tracing the ray of lights. So the first one, the direction here from right to left, so it will be issued from B from right to left, hitting the lens at this point. It will emerge passing through the image focus, and another one passing through the optical center. It will emerge without deviation. Okay, and by this we have finished explaining this method. So that's it for me in this video, guys. Hope it was beneficial for you guys out there watching it, and see you soon in another one.